have to take the English one, so.
Oh, okay.
3. Yeah.
It used to be that juniors and seniors didn't take them at all, didn't it?
Yeah, except for they changed it. Right?
Just in time.
Just the cutoff by a year.
Yeah, really. Well, you're going to have a similar thing happen on the SAT, it occurred to me.
Oh, really?
I think, let's see, maybe not. No, you're a junior, so you'll take it this year and in the fall probably. But in 2016, they're changing the SAT significantly. I can't remember all of the changes, but it's going to be a huge change. But by the time you would be taking that, that would be your second semester of your senior year, and you probably will already be accepted to a college by then. So I don't think you'll have to deal with it.
Okay, cool.
Yeah, well, I'm not sure it's necessarily going to become harder. I'm trying to remember some of the things they're changing about it. I can't, though. Anyway, I presume that's what you want to work on tonight?
Yeah, I just have a question about the SAT.
Okay.
Is this the one where you should answer all the questions, even if you have to guess? Or is that, what's the deal with, like
yeah, there you go. You just hit on one of the changes they're making. You just reminded me of that by saying that. One of the changes they're making is they're not going to penalize for wrong scores, for wrong answers. And you're right, they do penalize it for it now. And however, the penalty they assess are the same odds as getting it right if you guess. You know what I'm saying? From a probability point of view, there's no harm guessing, even though they penalize, because you might get penalized. Let's say you guess on 5 problems, and you guess correct once, and you guess incorrect 4 times. The net is the same as if you did not guess on any of them and left them blank. Okay?
Okay.
Whereas
so should you though?
with the ACT, you always want to guess. They don't penalize on the ACT. So some might argue that you wouldn't want to guess on the SAT. But I would argue the other way. Even now, for this year, I say guess. Even if you don't know, even if you don't have a clue and you're making a pure guess out of 5 choices, you're just as well off guessing as not. And
okay.
most of the time, you're going to be able to rule out 1 or 2 of those choices. So you're really going to be guessing, say, between 3 answers. And then you're much better off guessing than not. So
Okay. So, I was studying with a friend for the SAT this weekend, and there was something I was thinking I should ask, but I don't.
okay, well, if you remember it, just interrupt in the middle of what we're doing and say, oh, I remembered what I was thinking.
Okay.
Okay. The SAT loves these kind of questions, number 12. The sum of 5 consecutive integers is 500. What is the value of the median of those integers?
Okay. How would you?
Well, think about this. See if you can come up, read the details. It's the sum of 5 consecutive integers is 500. So each of these integers needs to be approximately where?
Less than
Close to 100,
100, yeah.
right? Because if I had 5 consecutive integers that added to 500, they would all have to average 500, which means I must have 98, 99, 100, 101, and 102. So what's the median of those integers?
Okay.
What's median? Yeah, median means middle. So 100, it also happens to be the mean of those 5 numbers, the average. But that isn't always the case, obviously. But they definitely ask you lots of questions about mean, median, and mode. All right, the 13 has to do with this graph.
Super.
Frequently, the toughest thing to do on these problems is the first step. If you can figure out what the first step is, then most of the time you can do the second step. So I'll give you the first step and I'll see if you know what the second step is. If k of minus 2, I know what k of x is, so what's k of minus 2? H of what?
Of negative 3?
Hold on. Just plug in minus 2 wherever you see x. That's what it means when you say k of a number is I'm going to plug in this number into this function wherever I see x. Okay? Now, so this becomes h of minus 1 plus 3. And now how do we answer that?
Would you put negative 1 in for...
Well, go up to this graph because this is h of x up here. So what is h of minus 1?
Oh, 1.
Okay. So it's 1 plus 3. So the answer is 4. Okay? But there's a lot of places in these exams where you really need to know this logic, where if I define a function, no matter how I define a function, say this, and I say, okay, what is f of 3? You plug in 3 for x. If I say, what is f of x plus 1? You plug in x plus 1 for x. So that would be x plus 1 quantity squared over 2. So this concept, when you're using f of x or h of x notation or k of x, if there's something other than x in there, you plug it into the function. Or you evaluate it if you have a graph. In other words, we don't know what h of x is algebraically. They didn't define it for us. But they did draw a picture of it. So we know that h of 0 is 0, h of negative 1 is 1, h of negative 2 is 2, and so forth. So we can figure out what h of any number is from the graph.
Okay. Would it be 25?
No? Let's work it out. How many different ways can these ponies be sized up? First person, has how many choices? Hold on a moment. Wow. Any of which would be suitable for any friend. So this guy has 5 ponies to choose from. This guy has also 5 ponies to choose from, not 4. In other words, this problem is not the first person gets to choose, and then the next person gets to choose, and the next person gets to choose. What they're saying is that any of the 5 could have any of 5 ponies. So it's 5 to the 5th power, which I believe is 625. Let's see, 5 squared is 25, and 125, and then 625 times 5. So it's 3125. Now, I have this little signal up here. 2 dots means there's a shortcut. And, I'm not sure why I have 2 dots there. I can't think of the shortcut. Because it's not 5 factorial, it's not combination or permutation problem. I don't think. I may want to come back to this. I want to look at their answer and then maybe come back to that. I may be missing something about this problem.
Okay.
Combinations and permutation problems have never been my forte. All right. First of all, you know what collinear means?
Does that mean that they're all on the same line?
Yeah. In other words, it's not obvious that ACD is a straight line. It almost looks to me like there's an optical illusion where there's an angle right here. But they're saying that A, C, and D are all on a straight line. Is what that statement says there.
Okay.
What's angle B equal to?
Angle B. Okay, so the line right there that's, wait.
Almost all the geometry problems, if they're asking you what's going on up here, you're going to have to start down here.
Yeah, so if you're looking, are X and, are both of those are equal, right?
Right. The fact that they're both called X means they are equal. Okay.
And
the key part here that I think you're missing is this part right here.
Isosceles. That means that B is going to be 130?
No. It's isosceles and that AC is equal to CB.
AC.
In other words, this is an isosceles triangle. This side's equal to that side.
Wouldn't that angle? Oh, because angle B is 50.
Okay. And
so outside, angle
all
B.
isosceles triangles not only have 2 equal sides, but their opposite angles are equal also. Okay, so this is 50. What's this?
That's going to be 80.
Okay. What's the sum of each of these?
100 and then 50.
Okay, so 50 is the answer.
Yeah.
Now when you're gridding that in, you don't put 50 degrees, you just put 50. I'll take a picture. Have you taken a PSAT where you had to grid those in yet?
Yeah.
Okay, so you're familiar with the gridding process.
Yeah.
It's not something we need to review. Okay, yeah. I think I've told you the only real important thing about it, which is that you can't grid in proper fractions. You cannot grid in an answer like 4 1/2. You have to grid it in as 9/2.
Okay.
In fact, if you were to grid in 4 1/2, it would read it as 4/41/2. So it would read it as 41 halves. And that's the only real peculiarity. Okay. All right, a symbol problem. They love these things too. What they're going to do, they show you the symbol, and they define what function that means, or what it means actually. In other words, if x right arrow y means you take 2x and add it to 3y. X left arrow y means you take 3x and add it to 2y. So, if 4 right arrow 3a equals 4 left arrow 3a, what's the value of a?
Wait, so A is the 2x plus 3y thing, right? It's your unknown?
Right. In other words, when I say x imply, or whatever you want to call that, right arrow means this, then what would it mean if I say 4 right arrow 3a?
Okay.
So what would that mean?
That would be 4 3 times 2x plus 3y?
Okay, we're going to substitute 4 for x.
Oh, so 4...
And we're going to substitute 3a for y.
Okay.
Okay, so 4 for x gives you 2 times 4.
Yeah.
Plus 3 times 3a.
Okay. Do you want to, like, solve that out, or do you want to leave
Not
it
yet.
first?
We'll get the essence of it here.
Okay.
And what does this mean? Use this formula.
Yeah. So then 4 times 3x.
Not times 3x. We're
No,
going to plug 4 in for x.
Yeah, and then plus 2 times 3x.
There you go. Okay. Now they're saying this is equal to this. So I'm going to set this equal to that, and that's going to allow me to solve for a. So I've got 8 plus 9a equals 12 plus 6a. Solve that.
So 3a plus equals 4. And then, so a is 3.
4/3.
Yeah.
And that's the way you want to grid it in, is like that. Now, what would also be acceptable here would be 1.3333.
No, because you have to go in.
I think you only have 5 slots, actually, so that would be acceptable.
Yeah.
All right. What would not be acceptable would be 1 1/3. All right. These are actually, I believe, the easiest problems in the test because they are strictly substitution. You always are, that means whatever is to the left of that arrow gets substituted for x, and whatever is to the right of the arrow gets substituted for y. And it's a little confusing because you're tempted to substitute the a for y and not the 3a, but you have to substitute the whole thing.
Tricky. So that's the coordinate plane. Ooh, I did one of those this weekend. And I got it right.
What's that?
Oh, when I was studying this weekend, I got one of these right. Let's see if I can.
Okay. So, intersects the line 5 comma S 11 comma D, what is the greatest possible slope of the line L? Wow, these are tough. Well, what might help here? A picture.
Yes.
What's the shape of this? What are we looking at here?
A parabola.
The vertical pointing up, vertical pointing down, or pointing to the right or the left?
Pointing up.
No, that's y equal x squared. In other words, the one that you've been taught all these years is that one.
So it would be pointing right?
To the right, yeah. If you remember your conics parabolas, you can have parabolas that look like this or that look like that. And they are of the form x equal y squared, not y equal x squared. So I know that if I had x equal y squared, it would be that one. Well, this is moved up by 3 units and vertical stretched by 2 units. So I'm probably looking at something that looks like this. Where this is 3. Okay? Now, they say there is a line L at 5 comma S. Well, here's 5. We'll make this S right here. So we'll have this line go through that point right there. That's 5, and this is S. And it also goes through 11 comma D. Well, let's put D up here. We don't know where S or D are, but there's an approximation of what would work here. Okay?
Okay.
Now, what is the greatest possible slope of that line?
Okay.
So the only thing we're allowed to move are D and S. In other words, we're stuck at 5 and 11, and with this sideways parabola whose vertex is at 3. So if I were to put D below S, so that, let's say I put D down here. Okay? So now this second point that's there would now be down here, giving you a negative slope. So we don't, no matter what, if D is below S, we're going to have a negative slope, correct?
Mm-hmm.
So the only way we get a positive slope is if D is above S.
Yeah, so we're assuming that that's the case because it has to be greatest, right?
Yeah, what's the greatest possible slope of line L? Well, obvious D is closer to S. Let's put D down here. That means this point is here, and that slope is closer to 0. So it would appear that as D gets further above S, the slope gets steeper and steeper. If I put S way down here, and I put D way up here, well, this point would be here. That point would still be there. and that slope would be steeper. Wow. This presents a dilemma.
Find the
What does that seem like the greatest possible slope must be? If I let d approach infinity, and I let s approach negative infinity, I have almost a vertical slope, right?
Yeah.
In other words, I can come close to a vertical slope here, which means the greatest possible slope would be almost vertical, which is undefined, which is infinity. But I can never reach that because there's always going to be a run of 6. So my numerator is the rise. In other words, let me take a little different approach here. My numerator has to be d, the slope of this line is the rise, d minus s, over the run, which is 6. So the greatest possible slope y is, what am I doing here wrong?
Do they give you like suggested answers for these, or?
Yeah, they do give us answers on this. Oops, I'm real curious on this one. I can't believe I haven't I must be doing something wrong. Let me see if I can find the answer to this one. 17, let's see. You know what, I might not have answers on this, but I have the book. Hold on. Test 4 answers. Oh my gosh. And in the answers, they give you the rating on the problem, and this is only medium. Must be making a mistake here. Oh, hold on a second. I wasn't in the math section. Okay, here. Let's see. Oh, in fact, I got to make sure I'm in. 4. Yeah, I hate the way the SAT breaks every chapter into 3 different sections. Oh, let's see. Hold on. I'm on page 295. So there's the question. Okay. Hold on. In section 4, I need answers. Test 4. You gotta be kidding. Section 4. I need answers to section 4, test 4. Okay. Here we go. Alright. High degree of difficulty. That's better. Interesting. They come down to the highest possible slope is d minus s over 6.
Oh, cool.
To make this as large as possible, choose d of 2 and s of minus 1. Which I don't get, because why are we limited to a d of 2? Ah. All right. Yeah, here. I know it's 7 o'clock. So let me real quickly show you what they do here that I wasn't doing. Yeah. They take the equation of the parabola, which I actually didn't consider, and I knew I needed to be, and so that becomes 2 equals 2s squared, or s squared equals 1. So s has to be either plus 1 or minus 1. And they do the same thing if they, and that's plugging in 5 and s. And if they plug in 11 and d, then they come up with 2 choices for d. D can either be plus or minus 2. And so if you're looking for the maximum that d minus s can be, you use the maximum d, the minimum s, and you get 3. So 3 over 6, the maximum slope can be 1/2.
Okay.
My apologies. I didn't
Cool. No, okay.
think like that, but I should have, because it clearly has to be related to that picture. I mean, this picture. All right. All right, Sarah. When are you taking this test?
The SAT in the fall, ACT later in the school year, like May.
Oh, I thought you were taking one in March. No?
No, there is one in March, but it's not the one I'm taking.
Okay. All right.
Yeah.
All right. Sounds good. Talk to you next week.
Thank you.
Bye-bye.